Today's video will explain how to design a large inheritance tree. Hello, I'm James Helfrich. It can be challenging to design a large inheritance tree so that it's adaptable. In other words, we can accommodate changing and new requirements by the client without fundamentally changing our overall design. This video will demonstrate one such technique using user interface elements otherwise known as widgets as an example. Okay, let's take a look at some best practices. Number one, every base class should map to a design concern. Every aspect of a design should map to a design concern, be that a function or a class. Sometimes we are tempted to add a base class to an inheritance tree that is not in the problem domain. This impacts alignment. Now recall that alignment is how well the structure of the inheritance tree maps the subject matter expert's conceptualization of the problem domain. Whenever we have extra classes in the inheritance tree that do not map to the problem domain, we have alignment challenges. Next, do not worry about balancing an inheritance tree. There is little benefit to a balanced inheritance tree. There's no performance win and no maintainability win. It is better not to devote effort to a constraint that does not improve the design. In fact, usually efforts to balance an inheritance tree as a distraction from the things that are truly important leads us to pursue a non-optimal design. Next, every level and inheritance tree should mean something. Not only should each class mean something, but each level should as well. It is best to clearly identify the levels early in the design process. Next, unambiguously communicate the meaning of each division and inheritance tree. And this relates to best practice 38.3. We should communicate our design strategy to the other members of the development team. This can be done in the code base with comments or through other team communication mediums. And finally, choose base class names carefully. A vague or generic class name is a good indication that it is not mapped to a design concern. Whenever you have difficulty naming something, reflect on whether that programming construct is really needed or whether you really understand it. Create a master plan for an inheritance tree representing the following problem. A graphical user interface consists of several types of widgets, buttons, scroll bars, edit controls, etc., each of which is made of several parts. The complete set of widgets and parts is not known at the beginning of the project. Okay, so our first step is to identify our levels here. So we're going to have the base class, and every widget shares the same base class. That's a given. Now the next level is going to be a compound widget. In other words, a widget built off other widgets. And there's going to be several of those. Next comes a simple widget. And this is a self-contained component that the user can interface with. And then finally, at the very bottom, we'll have a part, which is one object that may be drawn or accept input. Okay, so here's my basic overall plan. Now I'm going to try to identify the base classes. I'm going to say, well, the widget, that's the name of a base class. That's easy. Now my compound widget. So I'm going to have a scroll bar, but I'm also going to have edit control, spin widget, combo atomic drop down, preview control. I'm going to have many different things. Right now, we're going to focus on the scroll bar. Now, the scroll bar actually consists of a button and a thumb and a track, actually two buttons, the up and down arrow. Okay, so notice how that we had inheritance from the compound widget up to the base class, but now we have a composition from the simple widget to the compound widget. And that's because the scroll bar consists of many simple widgets. Now, let's take the button itself, and the button itself is going to have a label, but it'll also have the rectangle, and it's going to have composition as well. And so now we have our complete tree here, and each level is going to have a different semantic meaning. And observe also, and I really need to emphasize this, observe that a level may be inheritance or may be composition or aggregation or association. But in each case, we want to make sure we understand completely what the level represents. This is example 38.1 in the large inheritance tree chapter of the software design textbook.